The fastest way to fool yourself with an agent is to watch it succeed once. In a demo, the request is clean, the tools behave, and the answer looks confident. Then, production arrives. A user adds a constraint. A tool returns a weird error. Retrieval pulls the wrong document. The agent still answers, but now it's skipped verification or called the wrong API. Eval-driven development starts with this uncomfortable truth. An agent is not evaluated by one successful conversation. It is evaluated by what it does across a representative set of tasks, failures, and edge cases. A normal function has inputs and outputs. An agent has a trajectory. It reads the user request, chooses context, decides whether to call tools, formats, arguments, interprets results, maybe retries, and then writes the final answer. Every step can be right or wrong. The final response might look fine while the trace reveals a policy violation, an irrelevant retrieval result, or a lucky tool call. That is why agent evaluation has to inspect the behavior path, not only the last paragraph. Eval-driven development means you build the feedback loop before you trust the agent. You collect representative tasks. You define expected behavior. You run the agent. You score the result and inspect the trace. Then you compare a candidate version against the baseline before shipping. It is similar to test-driven development, but the assertions are often rubrics, comparisons, constraints, and human judgments instead of exact string matches. A useful golden task is more than a prompt. It says what the user asked, what context is available, which tools are allowed, what the agent must check, and what it must not do. For a refund agent, the golden task might require an order lookup, a policy check, no unsupported refund promise, and escalation when the policy is ambiguous. That turns vague quality into something you can rerun. Traces are the debugger for agent systems. A trace captures model calls, prompts, retrieved documents, tool arguments, tool results, retries, errors, latency, token usage, and feedback. Without traces, a bad answer is just a mystery. With traces, a failure becomes a concrete defect. The wrong document was retrieved, the tool schema was ambiguous, the model ignored a required check, or the timeout path never recovered. A good eval suite is a matrix. Rows are tasks, columns are metrics. One column asks whether the final answer solved the task. Another asks whether the right tool was called with valid arguments. Another checks whether retrieved context contained the answer. Others track format, policy compliance, latency, cost, and fallback behavior. This prevents one big quality number from hiding the thing that actually broke. Offline evals are the release gate. If you change the system prompt, swap the model, update the vector index, add memory, or modify a tool schema, run the fixed eval suite before deployment. The question is not whether the new version looks better on one example. The question is whether it improves the target cases without unacceptable regressions on important ones. Offline tests are necessary, but they are never complete. Production reveals new user intents, stale documents, tool outages, prompt injection attempts, latency spikes, and cost regressions. Online evals sample real traces, score them automatically when possible, route uncertain cases to humans, and turn new failures into new golden tasks. This is how the eval suite stays alive. LLM as judge can be useful for scoring tone, relevance, groundedness, or pairwise quality. But a judge model is still a model. It needs clear rubrics, examples, human audits, disagreement analysis, and thresholds for escalation. Human review is especially important for high-risk, subjective, or ambiguous tasks. The goal is not to remove judgment, it is to focus human judgment where it matters. The practical loop is simple: collect realistic tasks, capture traces, score behavior, compare versions, monitor production, send uncertain cases to review, Convert failures into new regression tests. Eval-driven development does not make agents perfect. It makes their failures visible, repeatable, and fixable.